Today we will start with, in the last session we had talked about interfaces. We talked about various things which we could do with interfaces. We talked about default interfaces. Then we talked about how do you use an interface reference. We also, I think, last session talked about lambda expressions and how to create a lambda expression. We also talked about the importance of lambda expressions in programming. And we said that lambda expression is the way functional programming is becoming part of object-oriented programming. So we stopped at this point. Okay. Today what we'll do is, we'll look at two important classes, one which we have been looking at for some time called string, and then we'll talk about string builder, which is a cousin of string. We'll talk about what are the, when do you use a string builder, when do you use a string, and then we'll go and talk about what are called final, what do you mean by that, final declaration, and static classes. Some of these ideas, some of you or many of you would have seen in C++, but I would like you to see it in a more comparative way. Now, I think there is, and I pointed this out, I think, there is a fundamental difference between string in Java and string in C++. That fundamental difference is very simple. A string in C++ is mutable. A string in Java is immutable. What does the word mutable mean? Ability to change. Now what does that mean? Okay. So I have touched upon this, but not with as much length or as much strength as is needed. So in C++, let's take the case of C++, let's take the case of Java. Some of this will be familiar. So I say string S is equal to, let's say, KMI. Okay. In Java also you can do, the class is string S again equal to KMI. This you can do in both languages. Only difference perhaps for those of you who have a good eye, this S is small and this S is big. The string in C++, the standard class string class in C++ starts with a small s, and here it starts with a big S. But then that is not the difference we are talking about, correct? So in C++, you can say S of, let's say, 0 is equal to T. You can do this, or I think I should put a single quote. This you can do in C++, and if you print S now, if you do a cout on S at this stage, you will get TMIT. Okay? This is what you will get. This will have effect. Now, can you do the same thing in Java? Can you say, single quote. Will this line work? No, this won't work, because Java, there is no mutation. You can't change a, you cannot add one of its characters to something else. You cannot do that. So this is not allowed. Okay? I'll give other examples of immutability, but this is not allowed. So if you want to do something like this, what do you need to do? You need to convert it into a character array, and then you can do it. But then when you convert it into a character array, it has already become an array of characters. So it is no longer a string. You cannot treat it as a string. So that's a completely different alteration that we do. So this is something to keep in mind, that this is illegal in Java. You can't do that. Okay. Now, but this is not such a crucial point to make. This is just an aside point to make. Now, I will do something very simple. Okay, just watch. I am now only in the Java world. I am not in the C++ world. So I will say string S1 is equal to, let's say again KMIT. Okay. then I will say S1 is equal to S1 plus let's say college. Now this line will work, and when I say SOP S1, then I will get as expected KMIT college. So this is going to work, there is no problem. But now the important thing to understand is this string and this S1 one and the same? That means at this moment what happened? An object was created on the heap. Actually we'll later know this is a literal heap, but doesn't matter. So KMIT was created on the heap, S1 was referring to it. This is what happened on this line. Now when I said S1 is equal to S plus college, what happened? Did this happen? That there was now a string called KMIT college and S1 is pointing to it, and what happened to that original KMIT? Is it still there or is it not there? Or that KMIT itself became KMIT college? Okay. So now what really happened? So this is the dilemma. What happened? Did the original string S1 stretch, expand to become S1 plus college, that is KMIT plus college or KMIT college? Did this S1 expand to become bigger, or like this, or a fresh S1 was created? What do you think happened? Did the original S1 expand? Is our S1 elastic? So the important point to understand here is S1 can never change, and that is what we mean by immutability. So when I did that, look at that line, S1 is equal to KMIT. A string was created, all right, that was created on the heap, and S1 was referring to it. When I said S1 is equal to S1 plus college, what happened? Yet another string got created on the heap, and now that S1 which was earlier pointing to KMIT is now pointing to KMIT college. Now what you should wonder about is what happened to that old guy, that KMIT string that remained on the heap. That old KMIT is still there on the heap. New KMIT college is created and S1 is now pointing to KMIT college. So who is pointing to the old KMIT? No one. No one is pointing to the old KMIT. That KMIT which was created first, no one is pointing to it. Correct? So that is called a orphaned object, and ORN we use the word eligible object, eligible for garbage collection. So sooner or later, so at this stage, what is important to understand is there are two objects on the heap. One is KMIT, the other is KMIT college. The original KMIT, nobody is referring to it. Whatever S1 is referring to is KMIT college. So this is called the immutability. Now, why did they do it this way? Okay. Why do you think they did it this way? Why couldn't they have stretched the original string when you add something to it and allowed it to become bigger, or shrunk? It could have also shrunk, correct? If I have a bigger string and I make it equal to a smaller string, can it shrink? Well, in this case it cannot shrink also. The original will be abandoned and the new one will be created. So why did they design it this way? This is how it is. But my question is not what it is, but why is it the way it is? Any reason you can think of? In simple question I am asking is, why did Java decide to make strings immutable? No one? Any guess? Why did they make it immutable? The fact is, it is immutable. And C++ doesn't have it immutable. So there must be a reason, right? Okay, the reason is something like this. If you make things immutable, then the amount of management that you have to do for that object is large, is huge. Meaning, suppose I want to make it immutable, string immutable, what I will have to do? First, when it stretches, then I will have to allocate another piece of memory, that even here I have to do. But then, that memory, how will I have to manage? Because my original S1 will be pointing to that. From there, I will have to point to, because if I am not creating a new object, if I have to expand or shrink that object, one lucky thing that can happen is if there is enough free memory available after this KMIT, so it can expand. But suppose, imagine that memory is not available, that memory is occupied by somebody else, because you don't know beforehand that this string is going to expand. When you allocate memory, or when the kernel allocates memory, when the JVM allocates memory, it has no dream that you are going to make it KMIT college. It doesn't know. So it will allocate some memory, and adjacent to that, it will allocate some other memory, correct? Now, if there is no amount of memory to stretch in that area, there is no free memory, there is no contiguous memory, what will have to happen? That we will have to maintain S1 pointing there. From there, we will have to maintain a pointer to this new version because it cannot expand there, and my original pointer must point there because I cannot change it, and that causes a lot of problem. The reason it causes a lot of problem is because the memory management becomes complex, and sometimes it may so happen. Just imagine this. I think you have to learn to think this way. Just imagine something like this. Okay. Imagine a piece of program which starts with string S1 is equal to KMIT. It starts with this. Then I do S1 is equal to S1 plus college. Then I say S1, little later in the program, I say S1 plus situated in Hyderabad. And just imagine what I would have to do if I have to make this immutable. First, I would have to allocate KMIT and make S1 point to that. Then I would have to say KMIT college. Now if there is no memory after this and my S1 has to continue to point here, I'll have to put something which says this is invalid. I'll have to do that, and then I'll have to keep a pointer here, somewhere here, which takes me to KMIT college, and when I expand that further, I'll have to again invalidate that and keep a pointer here which internally, which refers to KMIT college situated in Hyderabad. Okay, all that. Now, when I have to access S1, what I would have to do? Because I am not changing the address of S1, but I don't have memory there. So I have an internal reference going here, yet another internal reference going here. This is done in some of the languages, okay? And you know what will happen? In order to get KMIT colleges in Hyderabad, instead of going to one reference, and I'll have to go through 3 references, or maybe more, if you allow this to go on. So this is foolish. And why they did that is they said, as it is, Java runs on a virtual machine, so it is slow, and string is the most popular class. If you see, 80% of our program surrounds or works on strings, because that's the most de facto data type or de facto class that we use. If this itself you are going to make it so slow, and you are going to access it so frequently, and then you are going to go through this rigmarole of so many references, then the whole language will suffer as a performance, in terms of performance. So they said, we cannot afford to make strings mutable. They cannot change. Whenever a fresh string is there, we'll just throw away the previous one. It will get orphaned, and a new one will be created. We cannot keep links like that, where you keep the pointer reference constant, and then allow that pointer reference to continue further. That will not, like what I have just described. This cannot be tolerated. We cannot have that kind of thing, especially for a popular class called string. We cannot afford to do that. So they said, we will not make strings mutable. They cannot change. They have to be immutable, which means what? This is what it is. If you don't like it, throw it away. Throw it away means discard it, I will give you a new one. I will not keep any link with the older one that it expanded and became this. So that is the reason, that is the motivation for making strings immutable in Java. And there are consequences of that, that whenever you are creating this, okay, we can do a basic check about the immutability. Let's see what happens. Okay, so I'll say string s1 is equal to kmit. Then I'll say string s2 is equal to s1. I'll write that. Once I have written that, then what do is I say s1 is equal to s1 plus college, and then I say boolean b equal to s1 equal s2. Will this be true or false? Then I say SOP on boolean. What will it give? If what we are saying is true, then it should give a false. Correct? Why should it give a false? Because original S1 is pointing to KMIT, S2 is equal to S1. So where will S2 point? Again to the KMIT, and S1 will then change to S1 plus college, which, as I said, is not going to be expanding that original thing. That address will go away, and there will be another KMIT college getting created, to which this S1 will point. So if you compare these two references, S2 and S1, you can't see the references, but nobody can stop you from comparing references. So if you say S2 equal S1, you are going to get a false. Let's just prove it to ourselves for a bit, and I think you can also try this because it will set in your mind that strings are immutable. Okay. Day 9, lab 1. That is the one we are doing. We'll just quickly start playing with it. So, public class test. Yeah, string s is equal to kmit. Then we are saying string s1 is equal to s. Okay. Then we are saying s is equal to s plus college, space college. Then we are saying boolean b equal to s1 equal s. Then we'll print the boolean system.out b. Okay, so I should get a false. Then I'll do one more thing and then we'll move on. So as expected, you got a false. Yes, you should be getting a false too. No, yes. Are you understanding why you are getting a false? Understanding false is important because you have to understand that a new string object is getting created in your program. The old string object is as it is, and there is a fresh string object which has been created. So if you want to draw it, I think you can draw what is happening here. What is happening here is there is S, which is originally pointing to KMIT, and then there is S1, which is also pointing to KMIT, okay, because S1 equal to S. Then this S, this is cut, and this S is now pointing to KMIT college. So now we are comparing this reference with this reference, if this had not changed when you did this, then they would be same, but they are different. Okay? That's why you are getting a false. Okay. Now, this is what actually happened. Okay. So, I think this is that way self-explanatory. Now, I'm going to show you one more thing about strings, and then we are going to move on. This is very important. So please try and understand. Not many people understand this part. So just try and understand what is going on here. Okay. Okay. I'm going to the code. Just try and understand. String S1 is equal to KMI. String S2 is equal to KMI. Now, Boolean B equal to S1 equal S2. SOP B. Okay. What will I get? True or false? Think and tell. What will I get? True? Sure? False? How many objects are created? So should I get a true or a false? I am comparing the references, right? So should I get a true or a false? False. I have convinced you that you will get a false. No?
String pool.
Fantastic. What?
String pool.
So?
If you get same object, it will again point back to the same.
Fantastic. Beautiful. Yeah. Very, very good point. See what is happening here. I'll give another example, then you'll appreciate the difference. Okay, but just understand what is happening here first. Okay. What is happening here is S1 is equal to KMIT. S2 is equal to KMIT. But look at the right hand side. Am I using new there? Whenever we create normally objects using new, they are created on the heap. In this case, I have not used new. Can you see new? No. I have, in this case, KMIT is created alright. But when it sees the first line string S1 is equal to KMIT, as the gentleman rightly said, what happens without the new is a literal pool exists in Java. This is called literal creation. I am not using the new. When I am not using the new, they say, or Java compiler says, this is, I am trying to create a string object literally by giving double quote directly, no new. So, in this case, the allocation of this object is not in the standard heap of Java, it is in a special heap. This heap is called a literal pool of literals, swimming pool of literals, not swimming pool, but it's a pool of literals. It's a pool of literals. It's created in a separate piece of memory, earmarked for literal pools. The unique thing about literal pools is, when I try to do it again, S2 is equal to KMIT, again the Java compiler sees it's a literal pool creation. What it does is, in the literal pool, it goes and searches, is this kind of a literal already existing in the literal pool? Yes, it is. Then it doesn't create a fresh object in the literal pool. This behavior is only for the literal pool. So, when an object is created in the literal pool, or when you try to create another object in the literal pool, first a check is made, does this object already exist in the literal pool? For the first time it is not existing, so it is created. But when you do it the second time, the object is already there in the literal pool. KMIT is there in the literal pool very much. Because it is there in the literal pool, what Java immediately decides, this is already there in the literal pool, I will give a reference to that only. I will not create a fresh object in the literal pool. So, in this case when I say S2 equal to KMIT and then I say S1 equal S2, they will be same because the objects are in the literal pool. This is only for the literal pool. Now why should you know this? This you should know because if you want to improve performance, it won't matter in second year. But in third year, when we care a lot about performance and complexity and all, creating it this way is faster, far more faster, because it doesn't create repeated objects. But this is possible only when you know the string beforehand, when you are able to use a literal pool. So you'll see smart Java programmers always use this. They don't say new string KMIT. When you say new string, when you are using some kind of variable which you are reading from the system, or you are getting the data from somewhere, that is when you say new string. But when you know what that string is ought to be or going to be, no experienced Java programmer will ever say new string that, because he knows this will go into the standard heap, and when he tries to create something like this again, it is going to create yet another object and slow things down. Whereas in this case, because it is using the literal pool, and literal pool is very smart, it knows this has been created before and gives a reference. Okay, so we will just run this and check, and let's see what we get. So string S is equal to KMIT, string S1 also is equal to KMIT. We can comment out that line, and now we will print S1 equal to S. Okay? We will get a yes, true. Okay. Now just understand. See, you got a true. Okay. Everybody clear why we got a true? Because it was created in the literal pool. Now, if I change it a little bit and say I want it to be created in a normal way. Okay. If I say here, in this case, I change this line to new string KMIT and new string KMIT. Okay. Then you will see if I do this, what will I get? Will I get a true or I will get a false? What will I get? Obviously I will get a false, because now these objects, because I use the word new, they are going to get created not in the literal pool, they are going to get created in the standard memory pool, that is standard heap of Java. It's not smart enough to check whether it has been already created. If it is already created, I will give the reference to that only again. I will not create it again. That happens only in the literal pool. I have not asked for a literal pool. So then it won't work. Okay. So now you will get a false. Though we are trying to do essentially the same thing. But anyway. So as observed, we are getting a false. I hope everybody understands why we are getting a false in this case, and we got a true in an earlier case. The only change was, instead of creating in the literal pool, now we are creating in the regular heap using new. Now you will say, if one of them I create in the literal pool, one of them you create in the heap, what will happen? Obviously I will get a false. One is in literal pool, one is in the heap. Correct? So let's do that for the sake of doing it. So look at this. I will get a false now. I have to get a false because one is in the literal pool and one is in the, you see, we get a false. Okay? Yes? No? Are you understanding why we are getting the true and why are we getting the false? It should be very clear. Okay. Now we will do one more thing. Okay. This is interesting. Okay. Just see what call I am making. Okay. And then you will understand what is happening. I will say string S3 is equal to S1 dot intern semicolon. Now I will say S2 and S3 I will compare and see what we get. Just watch. Okay. See, I got a true. Now, you will have to tell me. I'm not going to tell you. First, you think and tell me. What do you think is happening? I've used a nice method on the S2 called intern. What do you think happened? Now it's true. I'm comparing S2 and S3. S3 is created from S1. Come on guys, think.
S3 is pointing to same object where S1 was pointing.
Correct. So what happened because of that intern?
Yeah.
Anyone? Sorry? Okay, good. So what happened was, when I said S1 dot intern, what do you mean by intern? You all know what is internship. When we are saying S1 dot intern, we are asking S1 to internalize itself, that is shift from the memory heap to the literal pool. And what happened is, when S1 was internalizing its string, that is whatever S1 had right now was KMIT. Now it was saying, intern tells it, go and create it in the internal pool, in the literal pool. When it was going to create it in the literal pool, what happened? There is already a KMIT there. So that reference was given back into S3 because there is a KMIT already created in the literal pool. That was created because of line 4. KMIT was created in the literal pool. So when I tried to internalize it and shift it to the literal pool, that string, already there is a string in the literal pool, that got returned, that reference got returned. And that's why S3 and S2 are one and the same. They are pointing to the same object in the literal pool. And therefore, when I say S2 equal S3, it is same. If I say S1 equal S3, it won't be same. S1 is in the heap, S3 is in the pool, literal pool. So it won't be same. But S2 and S3 are same because both are pointing to that same object in the literal pool, same string object. Okay. So this is what we talked about as far as string objects are concerned. We talked about what are the methods so many days. We also talked about an important attribute called immutability. That is what we talked about today. That we demonstrated that a string is immutable. How did we demonstrate? By making S1 point to something, assigning S2 to that, then changing S1 to something else, which caused a different string object to be created. And when we compared it with the earlier reference, it gave us a false. Then we also looked at what is literal pool, that there are two pools of memory. When does an object, string object go into literal pool? When you just put double quotes and assign it. When does an object go into the heap? When I say new, then we said, how do you shift an object from the heap to the literal pool? It is the internal, and this gives you huge benefits in performance if you are literal pooling or shifting it to the literal pool. That is internally lot of elements. Lot of popular strings are intern. Okay. Now we will talk about another class which is called a string builder. Okay. There are two classes which are kind of cousins of each other. One is called the string builder, the other is called string buffer. Their methods are same, but there is a small difference in the way they are created. We'll discuss the difference, but first let's talk about why Java felt the need for having a string builder. Well, the need came from the same need that of mutability. People said this string being immutable, creating a lot of objects, all of that is becoming a pain from a performance point of view. That, whenever I am creating I am concatenating to a new string object is getting created, all of that is happening. So there are too many string objects getting created on the heap. There is a danger that the heap will soon become full and then the garbage collector will have to be called. Now, people don't like the garbage collector too much because when the garbage collector gets called internally, everything that is happening in all the programs running on that JVM come to a halt. So people don't like the garbage collector to come too often. And when does that happen? When there are too many objects which are orphaned. And as we just demonstrated, string actually creates a lot of objects when you are adding to strings periodically, and you write so many programs where in every loop you are adding to a string, so much of garbage is getting created. If you create too much garbage, garbage collector comes in. Garbage collector comes in, performance drops. So people don't like garbage collector coming in too often. So there has to be an alternative found where the object doesn't change and become garbage collectible every time. So they created a stretchable version of string, a cousin of string called string builder. So if you ask what is the difference between string builder and string, by and large they do the same thing. One is mutable, the other is immutable. The string is immutable and string builder or string buffer are mutable. So we'll just quickly look at this class called string builder from the Java documentation, and then we'll briefly talk about string buffer. But let's talk about string buffer later. Let's just see what is it that the string builder has to offer in terms of mutability. It's a changeable version. So let's look at the methods. You see interesting methods right away. There is an append method which was never there in string. String append was plus. Here there is a regular append method, and the same string object expands. String builder object expands. The reference doesn't change. We'll demonstrate that. Then append is one. I'm not going to go through each version of append. Append anything that can be appended. Then there is a capacity. See, the way string builder works is when it is allocated first time, in order to avoid too much stretching, they first create it with a limited capacity, and as you need more, they keep on expanding it. So initially, even though you may be creating a string builder of 4 characters, internally it will allocate 16 characters. Why 16? So that when it is expanding, you don't have to expand it too much. You don't have to expand it every time. But the problem with string builder is that if you expand it beyond that initial allocation, internally it has to create another memory. You won't know it, but internally it would have allocated another memory. Your reference will stay the same. Okay? So there is string builder. Now it also has a caret method. These methods are not used much. This is important. It has a delete method, again to do with the mutability. Obviously mutability means not just appending, it can also do delete from this point to this point, like slicing in Python. Then delete character at, get character, index of both. This is there in strings also. So index of is there, insert is there, append is there, insert is there, delete is there. Then going further, last index of, first index of is all same. Replace is there. Replace was not there in string. No, yes. For obvious reason, it is immutable. How can you replace? Here it is mutable, so replace is there. Replace is very powerful because a portion of a string can be replaced with something else. So we have replace. Reverse is there. This is a very common question. A common question there were some smart people who used to do what? They used to convert a string into string builder. In string builder there was a ready-made method called reverse. Reverse it in string builder, bring it back into string. So go from string to string builder, reverse the string in string builder, bring it back to string and say I have converted. Then they used to say no, show me converting by doing it properly, by doing that reverse of a string, right? Don't show it to me like doing string builder conversion. Okay. So string builder reverse is there. Then subsequence is also a good method, but this is giving a start, giving an end, it gets that. Substring is very common, same thing as what we use in string. Then we have toString and trim to size. Trim to size is rarely used, that is just to reduce the internal storage. ToString is to bring it back from string builder to string. Okay, so that is called ToString. Now we will demonstrate very quickly what is string builder? Very quickly, I'll write one or two methods, remaining methods you can figure out. Okay. So, we'll remove this part. Okay. So, we'll create string builder SB. Okay. Is equal to new string builder KMIT. It is taking that constructor now, no? Double quotes. Okay, we'll check. Yeah, then we'll say string builder SB1 is equal to SB. Then we'll say SB dot append college. Then we will say Boolean B is equal to SB1 equal SB. Same thing what I have demonstrated earlier. Now, will I get a true or I will get a false? Guys, think. Will I get a true or will I get a false? True. Okay. Does everybody agree I will get a true? What am I doing? First I am creating a string builder object, calling it KMIT, then with a string KMIT, then I am creating SB1 and making it point to the same string builder object, right? So SB1 and SB are both referring to the same object on the heap called KMIT, correct? Then what am I doing? Then I am saying to that SB append college, so that SB is changing, it is becoming KMIT college, and then I am saying I will compare the earlier reference and the new reference or whatever, SB1 and SB. Let's see what we get. Okay, now as expected we are getting a true. You know what happened? Remember, string builder is mutable. String is not mutable. That time it had created a fresh string. So equivalent was not true. We had got a false for an equivalent thing. Now what is happening? Okay, just to demonstrate, for those of you who are a little thick, yeah, what happened? First SB was there, SB pointed to KMIT, then SB1 equal to SB, then this line SB dot append college. Now a fresh one is not created like this because this is mutable. So this itself became KMIT college. This could stretch, and therefore because a new SB was not created, the same SB could expand. This append method is provided by string builder, and therefore this is good. So we got true. Okay, so this became true. So this is what happened. So this KMIT could expand because it didn't have to create a fresh college. Had I had string and I had said S is equal to S plus college, which I did in the earlier situation, I would have got a different college. I would have got a different string, right? So let's keep that in mind and proceed. So now I have a string builder, okay, which is very good and which is able to expand. But even then you will realize that string builder is not preferred. By default we always use string, and we encourage programmers to use string only. Why? Because string builder is extraordinarily slow. Only you should use it when you know beforehand that you are going to expand it, you are going to shrink it, you are going to insert characters in it. Then only use string builder. Don't make it an object of first choice, a class of first choice. No, it is very slow. And though it looks very attractive, I can append to it, I can reverse it, I can insert it, I can delete it. From a programming point of view, unless there is going to be a lot of mutation to a given string, all programmers are advised not to utilize string builder. It is there, but only when mutations are too many, not otherwise. Don't use it by default. By default you should use string only, though it is immutable, but because it is immutable, it is fast. This is mutable but slow, like no free lunch, right? So you will get slowed down. Okay, now we have discussed string builder, we have seen its methods, and I don't know whether there's anything more left in string builder. This is toString, you can always bring it back, and substring you already know. Okay, since we are on that topic, there is a cousin of string builder called, well, string itself is a cousin of string builder. There is one more kind of string builder called string buffer. Now, what is string buffer? Okay, string buffer is said to be thread safe. Okay, I know I have not discussed threading yet, but I think this is a good time for you to understand what is the difference between string builder and string buffer. At this stage, you may not understand it fully. When we do threads, you'll understand it better. But nevertheless, I think a basic understanding is good to have at this stage, so I'll elaborate. String buffer is thread safe. Okay, let me elaborate what it means. Try and understand. There is string buffer, and there is string builder. As far as methods are concerned, they are identical. They are twins of each other. If you say what methods are supported on string builder, same methods are supported on string buffer also, no difference. But this is marked as thread safe, and this is marked as not thread safe. Okay. Now what does it mean? Okay. Imagine there are two threads in your program, T1, T2. Now you will say, what are these threads? Okay. Anyway, we will discuss threads at length. But at this stage, some of you must be attending this CUDA classes which we are doing. Anybody here? You are attending, good. If you are attending CUDA, you would have understood the importance of threads. No? Yes? For every thread, we give a thread ID, a block ID, and okay. At least you know there is something called a block ID and a thread ID. Okay. See, today, okay, let me go back a little. Why thread programming is so important today, and then we'll talk about why this is so crucial. Why is thread programming very crucial nowadays, and why you should learn it very intimately? You know, today, if you ask me, what is the single most common operation which is done on our computers, on your laptops, in real life? When you are playing a game, or you are doing an AI/ML program, or you are doing some image recognition program which is an AI/ML program, or you are doing advanced GPU computation, or some program in the area of fluid dynamics, computational fluid dynamics, whatever. Do you know what one single operation computer science people are interested in? Parallel processing is a term. The one operation which all of us get livelihood from, directly or indirectly. I make my money from that one operation, you make your money from that operation. What is that single most operation which a computer science engineer is extremely bothered about? Multitasking is not an operation. Multitasking is a concept. What is that one operation which is a bread and butter of computer science engineers? Are I am asking you, CUDA people are there, you should be able to get this. One operation. Somebody said? No. Sorry? Application. I'm sorry. Computing. Computing what? Everybody does computing. What computing? What is that one operation? Our livelihood depends on that, Baba. You, me, all of us live because of that operation. All is computing, all is everything. Matrix multiplication. You survive, I survive, the whole computing industry survives because of ability to do matrix multiplication. When you are dealing with graphics, when you are playing PUBG, what is happening? When a character is moving from here to there, what is happening? Matrix multiplication is happening. No? What is a character? Set of pixels. When you move a character from here to here, are the pixels of that character not getting multiplied with the pixels of that place where he is moving to? That is how the character appears as he is, no? I thought you knew all this. What do you, when you have played PUBG or some other game ever in your life? You have done? Good. Have you ever think when you are moving a character, what is happening? It's all matrix multiplication which is happening. Your scene is pictures. Your character is getting animated. How do you animate anything? By multiplying the pixels of that character with something. Isn't it? That is how you change color. How do you make a person move? By multiplying the matrix of the picture by something. That is called matrix transformation. Correct? So the crux of every operation is matrix multiplication. Those of you know AI a little bit, you know when you are designing a convolutional neural network or something, what are you doing? On an image, you are trying to recognize features. Here there is a face, here there is a car, here there is a house. What are you doing? You are multiplying the picture pixels with some filter pixels, and then when the comparison is matching, that filter is able to assess that. You know, oh, there is a camera here, there is a car here, there is a boy here, there is a girl here. How are you recognizing? Because you know what the result of multiplying a boy filter with that particular position, is it giving me a particular number? If it is giving me a particular number, I know there is a boy. If it is giving me a particular number, I know there is a car. If it is giving a particular number, I know it's a, two-wheeler, whatever. So, the whole thing of computer science is matrix multiplication. Now you'll ask, how is matrix multiplication related to threading? Again, very simple to understand. There are two ways of doing matrix multiplication. You have been taught one way. What have you been taught? When you multiply two matrices, take the row of one, multiply it with the column of other, and keep doing that for all the cells of the result matrix. Correct? That is how maths people look at multiplication. Can you afford to do that? Can you afford to multiply a row with a column? Your system will hang. You will never be able to play PUBG if you implement it that way. How is it implemented? For each row cell and each column cell, you have one thread. What is the job of that thread? To multiply one rows, one cell with another columns, one cell. Each thread will do it. And that thread will only multiply one particular cell of one with one particular cell of another. Right? One at a time. A combination of those multiplications will be one element of the result. When you add them up. Correct? But when you want to do it fast, this guy can't wait for the other. All of them simultaneously multiply their individual things, and somebody then aggregates it and produces the result. If you do it sequentially, if you write it the way you write matrix multiplication, what it will be doing? It will be adding one by one. Correct? K is equal to, you remember I, J, K. K is the common matrix. For K is, say first matrix is M into N. Second matrix is n into m or something, n into something, right? So k will be n. So you will write for I equal to 0, I less than k, I plus plus or whatever. That's how you will write. And then you will write a for, that internal for loop. Can you see that internal for loop in a matrix multiplication? That k, the common, the rows of the columns of the first matrix and the row of the second matrix. That k is that. Can you think in your mind at least? You have seen matrix multiplication. Can you see that for loop? Do you know that for loop is the biggest enemy of computer science? Learn to look at that for loop with suspicion. Look at it with anger. That is a for loop. Okay? That for loop you should not do a for at all. It should all happen in parallel. How do you make it happen in parallel? You have multiple threads going, each doing one step, one time. And one more thread which will add up whatever has been done cumulatively, not all at once, one by one. It will keep adding, right? And then the sum will be produced. So how much time will it take? Depends on the number of threads. If your matrix is 10,000 rows by 10,000 columns, how many threads are you going to need? How many threads will you need? For each row, each column, one thread. So you'll need 10,000 threads. And who is going to allow you to create 10,000 threads? If your laptop, can it create 10,000 threads? It will heat up and die, right? For that you require those GPUs, which will create 10,000 threads in 1 second and allow those threads to happen. So multi-threading is a very important idea. And as our CPUs have become GPUs and GPUs become more powerful or CPUs become more powerful, see today many of you must be having an 8 core, I don't know what is it, it's a 4 core or 8 core, the laptops. I think there will be many people in this class who will have an 8 core CPU. How many cores are there in our GPU? 48,000, right? 48,000, not one. You have 8 core. With 8 core also, if you are not having a multi-threaded program, your program will die. But, it will take too long. Now, I am not going to spend too much time on threading. Just see that there are two threads, T1 and T2. Now, both of the threads are working on, let's say, one SB. While thread T1 is doing something, thread T2 is also doing something. Now, SB, that is string builder, allows two threads to operate concurrently or simultaneously on one SB. That means when one thread is doing append XYZ and other thread is doing SB dot append ABC, okay. Now, this is potentially a dangerous operation if it is not thread safe. If it is a string builder, SB is string builder, let's say. What is the potential answer you can get? You can get X, A, B, C, Y, Z, or you can get X, Y, A, B, Z, C, or you can get X, Y, A, B, C, Z, or so many more. I hope you get the idea. I don't know how many of you grasp this idea. If my string builder is being worked on by two threads simultaneously, there is a risk. What is the risk? I may get unpredictable output. What my output may be? It may be, as I predicted, XYZ ABC, that is a predicted output. But another output could be XY AB ZC. When will that happen? It happens if the first thread gets that SB for some time. So the first thread got that SB for a little while, in which it could append only X and Y. By the time it could append Z, what happened? Its time slice was over and the string builder object shifted to the second thread. When it shifted to the second thread did AB, and by the time it would finish appending AB, it again came back to the first thread. When it came back to the first thread, he could do Z. Went back to the second thread, it did C. So what you expected was XYZ ABC. What you got was something else. Do you understand why that would happen? And that does happen. That is because string builder is not thread safe. Okay? Because it does not protect itself from locking. So it doesn't lock itself. That means when one thread is working on string builder, it doesn't keep itself locked from others. By not doing that, it allows this kind of thing to happen, where partly appending will happen as XY, partly it will happen as AB, again it will shift back and have another problem. So you have to understand that string builder is a dangerous guy because he is not thread safe. Because there is a possibility that two threads working on the same object, rare, but can happen, and computer science is a perfection science. It is not a science where you can say sometimes it will happen, sometimes it will not happen. We don't work in that. We work in the age of certainty, on the axiom of certainty. So we cannot guarantee on a string builder, you cannot guarantee that you will always get XYZ ABC or ABC XYZ, whatever. You can guarantee that. Whereas in string buffer, it is thread safe. That means when one thread is working on it, it locks itself from other threads. Other threads cannot act on it. So what will happen? In case of string build buffer, I would be 100% certain that I will get XYZ ABC. No, yes. Are you following what I am saying? Gone. This is important. You have to understand the difference between string buffer and string builder. String buffer protects itself, knows that it has to lock itself when an operation is going on. And string builder doesn't lock itself. It allows partly one thread to work, partly another thread to work. May happen. I am not saying it always happens, but may happen. Now, in spite of that, so if I say this and I stop here, what will you say? Which one will you use? String buffer or string builder? Buffer. Why will you use buffer? Because you will say it is safer and all that. Okay. But that is an obvious answer. String buffer I will use because it is thread safe. There is no danger of one guy overwriting the other, or one guy creating some output, other guy creating something else. That danger is not there. But do you know what is the reason why we still use string builder only, though it is not thread safe? That's because we care for performance. String buffer improves what you call thread behavior. It locks itself, but that locking makes it slow. So whenever something is happening, appending happening, first what string buffer has to do? Lock itself. When that appending is over, we unlock it. Okay? So that operation of locking and unlocking makes string buffer slow. String builder is not thread safe, but it is fast. So we always prefer a faster class, though there is a danger of this thing happening, that this kind of garbling will happen. Though it may happen, we still use string builder. We don't use string buffer much. Because string buffer, every time we use it, it's going to lock. Every time we stop using it, it's going to unlock. We cannot waste that much time. Always we care more for performance when we are doing regular programming. In some situations where there is too much of threading happening, then we go for string buffer. Otherwise we always go for string builder. But as a computer science student, you should be aware that in Java, there are many such classes. This is just one of the examples. There are many such classes which have two duals, or they have a dual. One of them is thread safe One of them is not thread safe. Now invariably our choice is don't use the thread safe version. Use the faster version. Unless there is a very, very clear reason that there is going to be huge amount of multi-threading, so it's better to use the thread safe version, which locks. So this happens in Java throughout, and unfortunately I have seen people who do Java for years don't understand why sometimes string buffer is coming, why sometimes string builder is coming, or it happens with other classes also. Then we'll move on. So we have talked about string buffer, string builder. We have also talked about mutability, immutability.